Yeah, well, I have a quiz tomorrow, and I'm still a little confused on the polynomial and factoring.
Okay.
So,
Um, so I take it you have not yet gotten to the point where they expect you to be able to do this one?
nope, not yet.
Okay, I figured that that's what we were going to be doing tonight. All right. You got
There's a couple that we didn't do that I didn't know how to do.
All right.
So,
why don't you go ahead and verbally read them to me, and we'll take a shot at them.
okay. And one set of parentheses is negative 7r, the second power, s.
Like this?
Yep.
Okay.
Minus 8rs. It's, sorry, it's in the same parentheses. My bad.
Well, you actually said it right. I wrote it wrong.
Oh, okay. And then,
In other words, you didn't say end parentheses. I assumed that. But,
okay.
so you actually stated it correctly. And then is this correct?
That's correct.
Okay.
And then it's going to be plus, and then another set of parentheses is going to be negative 3r to the power of 2s minus rs plus 2. And then that finishes that off. And it's going to be plus, and then the third set of parentheses is going to be negative 4rs plus 2.
All right. And our job is to simplify this?
Yep, find the sum.
I'm sorry, what?
Find the sum.
Oh, find the sum. Okay. And, all right, the second two sets of parentheses are not needed.
Okay.
The reason is because of this plus sign. That means I can eliminate all of these parentheses here. And this plus sign means I can eliminate all of these parentheses. And the first set of parentheses are not needed because they're at the front. So it turns out that I can just erase all my parentheses here and gather all my like terms.
Okay.
So how many r squared s's do we have?
2.
Got this one and this one. And what does that sum to?
It's going to be negative 9 r 2s.
Hold on. What's 7 and 3?
Or 10.
Okay.
My bad. Sorry.
R squared s is the way you verbalize that. Or r raised to the second power. But you don't want to just say r2s because r2s means that.
Okay.
But that's okay. Part of the advantage of verbalizing problems is you learn how to verbalize it. And that's something you don't get a lot of practice at in class. Because how often does the teacher ask you to stand up and verbalize a problem? Probably not very often.
Not yeah.
Okay. So how many RS's do we have?
3.
Okay, we got that one. Got that one. And we got this one. What are those total?
Okay, so that'd be 13. RS?
Is it positive? Yes, it's negative because each one of them has a negative sign in front of it. And what are our numbers total?
Let's see. There's 2 numbers, which add up to 4.
Okay. So there's our answer. Now, let's talk for a moment about why I was able to get rid of the parentheses. If the problem was the following, and that's a negative sign, Okay? This negative sign makes all the difference in the world. That means I can't get rid of the second set of parentheses. I can't just erase them. I have to distribute this negative sign to each term here. So when I get rid of the second set of parentheses, I never really need the first set of parentheses here. You just never do. When they're put in there, it's for clarification purposes. But if I'm reducing this expression, I can always get rid of the first set of parentheses. But then this negative sign has to apply to that. And what's the rest of it?
Plus 10?
Yeah. So notice I cannot just erase those parentheses. I can only do that if this is a plus sign. Then I can erase both of these parentheses. But when it's a minus sign, you have to make sure that minus sign gets distributed to each of these terms.
Okay.
All right. So what's another one you had that you weren't sure how to do?
Okay, well this is
Go ahead and read the parentheses if they're in your problem. A lot of times the parentheses are merely there for clarification. They're not there because they're needed. And that's okay. But it's important to know the difference.
Okay. So the in the first set it would be x to the power of 3 minus 2x plus 5. And then it's going to be minus. And the second set of parentheses is going to be 2x to the power of 3.
I'm sorry, what was in here? 2x what?
Power of 3.
Okay.
Minus 3x power of 2 plus 4x minus 3.
Okay. Eliminate all the parentheses and tell me what we have. Actually, you don't really need to do that step.
Okay.
Just start combining like terms. How many x cubes do we have?
2.
What's the net total of them?
It's going to be 3x cubed.
Hold on. If we have 1 minus 2, what's that equal to?
1.
Negative.
Oh, right, because you're subtracting.
Negative 1. Always remember one thing about subtraction. If you are subtracting a bigger number from a smaller number, your answer will always be negative. Okay? In other words, 2 minus 1 is plus 1. Therefore, 1 minus 2 has to be negative.
Okay.
Okay? So we got negative x cubed. That's how many. That takes care of that, and that takes care of those two. Now, how many x's? What's the net sum of our x's?
2, and then it's going to be, since it will just be a negative 6x,
Well,
right?
hold on. Let's just look at the coefficients. We got minus 2 minus a minus 3. What does that become?
Oh, that would be, when you're subtracting a subtraction, that becomes like addition,
Yes.
right? Okay, so it would be positive 1.
Right. So
Okay.
that's how many x's we have, is 1. And what about the numbers?
Well,
Hold on. Excuse me. I messed up here completely. I didn't see that.
I saw the 4x, and then I saw the negative 2x, and I thought it would be a negative 6.
Well, first of all, I messed up because we got a minus 2x there and a plus 4x over there. But we've got this minus 3x squared there. We have to account for that. And when you're talking polynomials, you want to put them in the order. In other words, we want to do the x squareds next. How many x squareds do we have?
1. And would that become a positive?
It does, but that's the only one we have.
So then plus 3x squared?
Yes.
Okay.
Now how many x's do we have?
6.
You got a minus 2x there.
Oh, negative 6.
Minus 4x. In other words, when I apply this minus sign to this term here, it's minus 4x. So what we really have is minus 2 minus a 4. And remember I said turn all of these into addition problems. Change the sign of that and the sign of that. Then we have minus 2 plus minus 4, which is minus 6. And finally our number.
Oh, sorry. So when you apply subtraction to the negative 3 becomes positive?
Yeah.
Okay, then it'll just be positive 8.
Exactly. And there's your answer.
Awesome.
Okay.
Okay, so this one is multiplication.
Okay.
It's x minus 4 in the first set of parentheses. And in the second one, it's 5x plus 2.
Okay. Now these parentheses have a different meaning than the other parentheses. They're not only used to isolate a binomial term, but they also mean multiplication, because there's nothing in between them. And when we mean multiplication, it's very important that we have both sets of parentheses. In other words, this is not the same as this. In this one, the only thing that's being multiplied is that. But in the first one, we're multiplying every term by every term. Have they taught you something called FOIL?
Yeah, they have. You do first, so like x times 5x, then the outside, then the inside, and then the last.
Okay. I don't like the term FOIL, and I'll tell you why.
Okay.
It works great when it's 2 terms by 2 terms.
But when it's 3 by 2, it doesn't work?
No, it really doesn't. But I tell you what does work for any combination is what I call ET-ET. ET-ET. Can you guess what that means? Every term by every term. And what I mean by that is, regardless of how many terms there are, in this case it's 2 terms times 2 terms, I'm going to do it like this. I'm going to multiply that by that, and then I'm going to multiply that by that, and then I'm going to multiply this one by that, and then I'm going to multiply this one by that. Okay. So let's do that. What do we get when we do that? What's x times 5x?
Just 6, or just 5x, my bad.
5x squared. In other words, when you multiply x times 5x, well, it's 1 times 5, but then it's x times x, which is x squared.
Okay. That confuses me.
Well, here's the key. When you multiply, that's the same base as that, right? Both have a hidden exponent of 1. So whenever you're multiplying same base, you add the exponents. So x times x is equal to x squared. If I had x squared times x squared, that would be x to the 4th. If I had x squared times x cubed, that would be x to the 5th. Okay, so you always add the exponents when you're multiplying. If you're dividing, you subtract the exponents. Okay, so the first term we get is 5x squared. What's the next one when I do this times this? And I think it's a good idea to do these in order, and you'll notice that I'm doing them in FOIL order. In other words, I did the first. Now I'm doing the outside. X times the 2. What's that?
2x.
Plus 2x, and we do need the sign. I can't just say 2x, because in this case it's being added to the first term.
Okay.
And the third term?
There'd be negative 20x.
And the last term.
Sorry. It'd be negative 8x.
Just 8. The result multiplying
okay.
is minus 4 times plus 2. Okay, simplify this.
Okay, so I combine them.
Combine only like terms.
Okay, so would it be 18x? You'd combine the two middle ones.
What's the sign?
So it'd be 5.
What's the sign in front of the 18?
Sign in front of it. Oh, plus. My bad.
No.
Oh, minus. It's a negative.
Right, because in other words, when we're doing 2 minus 20, again, a bigger number being subtracted from a smaller number always has to be negative. So when I combine these two, I get minus 18x, and then minus 8. There's only one number there. Okay. So this is your answer. And notice that my ET did it exactly the same way as FOIL does it. The difference is that ET works much better if my problem is this.
That's my next problem.
Oh, okay. Well, let's do that one. What is your next problem?
It's the first set of parentheses. It's x2 minus x plus 9 and times x minus 3 in the second set.
Okay. Now notice FOIL wouldn't work very good here.
Okay.
Because there's multiple insides. So FOIL doesn't really tell you how to do it. But ET does. And use the exact same pattern. In other words, don't mix it up. One of the mistakes I see a lot of students do is they'll multiply this times that, and then they'll multiply this times that, and then they'll multiply this times that, and before you know it, they're lost because they don't know what they've multiplied together and what they haven't.
So you have to do x to the second power to x and then negative 3?
Yes, do that one times that, always first, and then...
Could you do it the other way around, too?
Then that one times that, always second. In other words, work left to right, always.
Okay.
Then you'll never mess it up. No matter how many terms there are, I could do 5 terms times 6 terms if I wanted, and as long as I go in a certain method, I'm always going to be okay. So what's my first term? I'm going to write my answers down here.
Okay, would it be x to the power 3?
Right.
And then it would be x times negative 3. That'd be...
Hold on. Let's make sure we always do that to there, and then that same term to there.
Okay.
In other words, don't skip to this term yet. Finish multiplying the very first term by both terms.
So it would be negative 3x squared?
Now go to the second term.
My bad. Okay.
Well, you don't... Either way is correct, but what I'm trying to do is give you a way that you can memorize that you're never going to get it wrong in the future. In other words, if you always follow this exact methodology, you'll be good. So we've multiplied this term by both of these. Now let's take this term and multiply it by both of them.
So would that just be 0?
Remember, we're multiplying. We're not adding.
Oh, so that'd be negative 2x?
What's x times x?
Oh, x squared.
Okay. Negative x squared.
My bad. I really got to get that down.
Okay. What's the next term?
Okay, so it'll be 9 plus 9x.
Now hold on. We didn't finish multiplying that by everything. Remember, it's every term by every term.
I keep doing that. Okay. So then would it be a positive 3x?
Yeah. Now finally handle your 9.
Okay. So be plus 9x. And then it would be minus 27?
Yeah. This every term by every term, just always work from left to right. And always do all of these first, all of those second, all of those third.
Okay.
Now, let's combine like terms.
Okay. So, would you put the negative 3x squared and the negative x2 together?
Right. But let's start with the highest degree term, which is this one.
Okay.
There's usually only one of those on the left. So you can start right off by that. Okay.
Okay.
Now we're going to combine those two terms. What does that give us?
Negative 4x squared.
Good.
Oh, no, sorry.
No, that's right. That's right.
Oh, it is? Okay.
Hold on. Before we go on, what we're doing is we're doing minus 3 minus 1. Right?
Right.
We're going to change the sign, change that sign. Now we're doing minus 3 plus a minus 1.
Which is negative 4. Okay.
Okay. Okay. How many x's do we have?
2.
Well, I mean, what's their sum?
Oh, sorry. 12.
And finally, there's usually only one number in these kind of problems also. In other words, this term on the left and this term on the right are almost always going to be the only terms that have those, you know what I'm saying? In other words, whenever you do a problem like this, you're going to find that there's only going to be one x cubed, and there's only going to be one number. And it's everything in the middle that has to be combined. Okay? Usually. I mean, I can't think of any other situation, but this is very typical here. Okay.
Okay. So, next one is d plus 8 in the first set of parentheses. In the second set, it's d minus 9. Or d minus 8, I'm sorry.
Like that?
Yep.
Okay.
So, what you do...
same exact way, work from left to right.
Okay. So, would you do d to the power of 2?
Uh-huh.
Okay. And then it would be plus... No? Oh.
Got to do this one. Remember, work left to right and complete the left to right. In other words, the first part of the left to right was that one. The second part is that one.
Right.
And I understand that you can do it in a bunch of different ways. In other words, it would be okay to do this one next. The problem is that it's real easy to lose track of what you've done and what you haven't if you have more terms than just 2. When you have 2 terms, you could mix it up and nobody's going to know the difference. You're going to get the right answer and everything else. But what I'd like to see you do is memorize a pattern of doing these. So make sure your next term is this d times this minus 8.
So it would be negative 8d.
Okay. Next term?
Okay. It would be plus 8d.
And last term?
Be 64. No, negative 64. Minus 64.
Simplify.
So would the minus 8d and the plus 8d cancel each other out? So it'd be just d2 minus 64.
Right. Now, let's talk about this, because this has a lot of mathematical significance. This is called the difference of perfect squares.
Okay.
Notice that d squared is a perfect square, and 64 is a perfect square. And they're being subtracted. Okay? Well, the difference of perfect squares can be summed up like this. That is always going to be this. So when I have d squared minus 64, my a equals d, and my b equals 8. So d squared minus 64 is always going to factor as a minus 8, as d minus 8 times d plus 8.
That makes sense.
The reason I bring it up is because this is going to be a problem that you're going to have to do at least 200 times in the next 3 years.
Okay.
Seriously. Difference of perfect squares is something that you get taught in algebra, and it comes up over and over and over and over. And that's why I pointed out here. And what we had was kind of the reverse of it. In other words, notice that we started with the d plus 8 times the d minus 8. Well, once you get really familiar with difference of perfect squares, you would know instantly that that multiplied together to be d squared minus 64. In other words, as with a lot of math, you want to be able to go both ways. You want to be able to multiply those two things together, and you want to be able to separate or decompose or factor, whatever you want to call it, this. In other words, the next thing you're going to get to in terms of factoring, the last session we had, we did an awful lot of greatest common factor, right? Well, this is not greatest common factor. There's no greatest common factor that allows you to factor this. What it is realizing that we are looking at the difference of perfect squares. So I immediately know that that goes to d minus 8 times d plus 8. While we're on the subject, let me give you a few others. Let's see. Let me see you factor this. Notice difference of perfect squares. Incidentally, this is not difference of perfect squares. 2 is not a perfect square.
Okay.
So difference of perfect squares at this level of algebra only applies to numbers that are perfect squares.
Okay.
So how would x squared minus 1 factor?
Would it be x, and then would it be minus 1/2?
Just 1, because the square root of 1 is 1.
Okay, and then it'll be x plus 1.
Right. And even though the order of these doesn't matter, in other words, this is the same answer, again, this is a kind of problem where if you always memorize it a certain way, it's going to help you further down the line in math, because we end up having to memorize difference of perfect cubes and sum of perfect cubes. And so memorizing it in this method is helpful. Let me give you another one. Sissy.
Okay, so the first one be 2x minus 1, and the second one be 2x plus 1.
Very good.
Okay, so the 8x.
No.
The first one, 8x minus...
Not quite. We need the square root of that. What's the square root? What multiplies together to give 16x squared?
8x.
4x.
Oh, 4x.
Right?
Mm-hmm.
Okay. What goes here?
Would that be 5?
And then once you get the first term, the second term is always the conjugate.
So it'd be plus.
Right. And that's called a conjugate. In other words, when the only difference between these two terms is the sign in the middle, then you're talking about this this 4x plus 5 is the conjugate of that. So that's another good reason to memorize it as the minus. All right, that's difference of perfect squares, and that comes into play a lot. And what you're getting with these problems, or this particular problem, is the beginning of difference of perfect squares. In other words, they're giving it to you front to back here. They're letting you multiply the two things together and coming up with the answer. I didn't even have to go through it term by term. If I recognize that I am looking at difference of perfect squares, then I know the answer has to be d squared minus 64.
Okay.
All right. What's the next one you got?
Okay, the next one is a 4r plus 3s in the first set of parentheses, and then it has a squared symbol, so that means just copy it.
Like that?
Yeah.
Okay. That means that term is being squared. What that means is what you just said. That's what that means.
Okay.
So let's do from this step here. Let me erase the rest of this. Okay. What's the first term?
16r.
What's r times r?
R squared.
Okay.
And then it'll be plus 12 rs.
Good.
Okay. And then it'll be plus, and then it'll be 12 rs.
Good.
And then it'll be plus, and then it'll be 9x.
What's s times s?
S squared.
Okay. And the two middle terms can be simplified. In other words, we're usually looking at a case where the middle terms can be simplified. But the far term on the left, there's no other r squareds in our picture, and there's no other s squareds in our picture. So our final answer is what?
16r squared plus 24rs plus 9s
9s squared.
squared.
Okay. Now, let's talk about this problem, because this is also very significant in math. Another thing you're going to have to do at least 200 times is this. Well, if I square a plus b squared, I get a squared plus 2ab plus b squared.
Oh.
Notice that if I do the foiling, or ET, whatever you want to call it, this is what I get. Okay, and if it's a minus b quantity squared, then you get something extremely similar looking. The only difference is the sign in the middle. Now, why am I pointing this out? Because you're going to have to do it 200 times over the next 3 years, and anything you can do to simplify something is worth knowing. Okay? So, in other words, you don't always have to do all 4 steps of FOIL or all 4 steps of ET. If you know this shortcut, it helps. What was our problem? It was 4s or 4r
plus 3s
plus
squared.
3s. Well, what's a?
A?
Yeah, in our situation, in our particular problem here, a is
Oh, it's going to be 4r.
A is that. Okay, so square it, and I'll write it right there. In other words, what I'm doing, I'm going to erase the second one here just not to confuse anything. So we're going to use this, and instead of doing ET, we're going to base it off of our knowledge that whenever I take a binomial and square it, it ends up being this. So what's the first term?
With 16.
16r squared.
Yeah.
That's what a squared is. In other words, there's a.
Mm-hmm.
So a squared would be 4r times 4r. Okay? And the next term, the reason this is a shortcut is because I don't end up with 4 terms. I end up with only 3 terms right off the get-go, and I don't have to simplify anything. Well, what's 2 times a times b?
2 times a times b is
2
20.
times 4r times 3s.
Sweet. 24.
24rs.
Oh, wow. Okay. That's really helpful.
Yeah, it is. And then the final term is b squared. Well, b is 3s, so 9s squared.
Okay.
So, in other words, whenever you have to square any term, regardless of what it is, as long as it's a binomial, you can use this information to do it. And if it's a negative sign in front, the only difference is it becomes minus 2ab in the middle. Everything else is the same. The first thing...
So it'll be 16r squared minus 24r.
Exactly. If it was minus.
Okay. That makes sense.
And what this does is it saves you an immense amount of time over the next 3 years every time you run into one of these. And that's the only reason I'm pointing it out. Because you haven't really gotten to this yet. You're still working with the multiplying a binomial by a binomial. But it's worth knowing both of these things. Difference of perfect squares and binomial expansion. What do you have next?
This one is find the sum.
Okay.
First set of parentheses, it's 4r cubed s minus rs plus, this is the second set, 7r cubed s plus 8rs minus 3 plus, and this is the third one, 8rs plus 6.
Okay. What's our first step?
Okay. Sorry, I've taken so much information. Oh, don't we, since it's all plus, we can take away the parentheses?
Yeah. We never need the first set anyway. And the second set and the third set we can remove only because of those 2 plus signs. If one of those was a negative sign, we wouldn't be able to do it. We would have to distribute that negative to each term in the parentheses. But because it's a plus, when you distribute pluses to every term in the parentheses, it's basically the same as just removing the parentheses. Could always remove those. Now the only strange thing is I don't have a strange thing. Now gather all like terms. How many r cubed s's do we have?
2, and that'll be 11 3s.
Okay.
And then would be minus 17r.
Okay, we got a minus 1 there. We got plus 8 there. And we got plus 8 there. So what's minus 1 plus 8 plus 8?
17.
Plus 1 plus 8 plus 8 is 17. So this can't be 17. And that's a good thing to know when you're doing arithmetic. Is know that if you were adding 1 plus 8 plus 8, you'd get...
My bad. 15.
15, exactly. And it's a plus.
My bad.
There's more pluses. There's 16 pluses. There's only 1 negative.
Okay.
Okay. So that's how many RS's, and then that takes care of that, that, and that. The only thing we have left is numbers. What do we got?
Plus 3? Okay. Awesome. Okay, this one says find the difference.
Okay.
On the first set, it's 7a squared plus 3a minus, and in the second one, it's 5a squared plus 5a plus 4.
Alright, there's two things you can do here. You can just solve it by combining all like terms and not worry about the parentheses. Or you can change it into an addition problem. Notice that if I want to change this into an addition problem, I make this a plus instead of a minus, but then I have to change the sign on every term that's inside the parentheses.
So there'll be negative?
Well, let's just go through it. I want you to know how to do it multiple ways. So I'm going to turn that to a plus, and then that becomes minus 5a squared. This becomes minus 5a, and this becomes minus 4. In other words, what I really did was distribute the negative sign to every term. Now I can get rid of the parentheses, and the only odd thing I have is a plus and a minus there. Which one should I erase?
A plus.
Okay, now combine like terms. What do we got?
Okay, so it'll be, let's see, 2a squared. And then it'll be, let's see, be a minus 2a. And then minus 4. Okay.
Now, we didn't necessarily need to do all of that, change that to a plus and change all the signs there.
It makes it a lot easier when you change all the signs.
It makes it so that you're never going to make a mistake. If you try to do this directly, you can still do it. Notice that we still have 7a squared minus 5a squared. So we still get that. Now we have 3a minus 5a, so we still get that. And now we have minus plus 4, so we still get that. So it's a little extra work to go through and change each sign, but
it's worth it.
Well, I don't know if it's worth it or not. It really kind of depends on the person. If you can do this 100% correct every time without going through those intermediate steps, then it's worth doing. In other words, whatever saves time works. But if you start making mistakes, where it usually causes people to make a mistake is, there's the problem right there. If I make that last term a minus 4, then an awful lot of people end up with this as their answer. They don't attach that minus sign to that minus sign and turn it into that, which is the correct answer. So it kind of depends on whether you're going to end up making mistakes or not. If you're not going to make mistakes, you don't need to do those intermediate steps. But if you find yourself making mistakes where you get the wrong sign on terms, then it's probably worth doing those intermediate steps. By the intermediate step, I mean changing it to an addition problem. But notice, the moment I do that, I have to change the sign on every single term. All right.
Okay. This one's a factor.
Okay.
And it's 20a cubed plus 68a squared.
Plus 6 or 60?
68.
Oh, 68.
A. Yeah, that's that.
Okay. What's greatest, and that's it?
That's it.
Okay. So the first thing you always want to look for when you're factoring something is there a greatest common factor?
Yeah.
Yes, there is. There's at least a number, and there's also a variable. I can see that the variable is a greatest common factor. So what's the number part?
2.
All right. What's the letter part?
would be 2, right?
Be a squared.
Oh, a squared, my bad.
All right, what's left over?
After you divide.
Uh-huh.
Okay, for the first one's going to be 0,
20 divided by 2. 20a cubed divided by 2a squared
is 10.
is 10a. In other words, here's what we have. We have 20a cubed divided by 2a squared. Well, the 20 divided by 2 is 10, but the a cubed divided by a squared, remember you subtract the exponents.
It was a 1,
Right.
which is just a.
Right, exactly.
Okay.
Okay? And then what goes over here?
Okay, here, let me get a calculator.
Well, cut 68 in half. That's all you have to do. To divide by 2,
Oh, that's 34.
34, exactly. Now,
Okay.
there's a problem with this answer.
Okay.
What is it? When I said divide by the greatest common factor, I can take another 2 out of this. Right? Because I could divide 10a by 2 and get 5a, and I can divide 34 by 2 and get 17.
Okay.
Which means, which tells me that I didn't take the greatest number out.
4.
Exactly. 4 would be.
Okay.
And that's the way you find out, is that if you make a mistake, you end up with something in the parentheses that can still be factored. Now this becomes 5a plus 17. Okay? Now, if I look to see, did I really take the greatest common factor out, it'll tell me. If I can factor that further, I did not. But I can't factor it further.
Okay.
So that's how you tell. And a lot of times it's tough to tell what the greatest common factor for a number is. In other words, I don't blame you for thinking 2 was the greatest common number. But in fact, it was 4. But that's okay. You can do it piecemeal. You could even do it like this. Let's even do it the way you started to do it. Well, now I can take a 2 out of that, so what I really have is 2a squared times 2 times 5a plus 17. And now I can multiply those two things together to get 4a squared. So my point is that you don't have to be perfect. You don't have to come up with the perfect greatest common factor. Just make sure that it's fully factored. And if you make sure it's fully factored, you'll always have the right number. It's kind of like simplifying that. Have you dealt with square roots yet? Radicals? Well, if I'm trying to simplify square root of 80, I know that 4 is a perfect square, so that's 4 times 20, which is 2 square roots of 20. But then 20 has some perfect squares with it. It's 2 times the square root of 4 times the square root of 5. Well, square root of 4 is 2. So I get to 4 square roots of 5 is what the square root of 80 is. I'd have gotten there a lot faster if I'd have recognized that the square root of 80 is the square root of 16 times the square root of 5, and the square root of 16 is 4. So I get there immediately if I recognize this, but even if I don't, I still eventually get there. Same exact thing with greatest common factor. If you don't happen to spot the greatest number, or even the greatest letter, you still will get the problem correct as long as you keep attacking the problem until you get it factored all the way down. You know what I'm saying?
Okay. Yeah,
okay. What else you got?
Okay, the next one is to solve for the equation 40x squared
40?
minus 15x equals 0.
Okay. These are always factoring problems. Why is this a factoring problem immediately? When I look at it, I know it's a factoring problem.
It's equal to 0.
What's that?
It's equal to 0.
Well, that's a clue. That means that if I can get this as A times B equals 0, well then I can say that either A is 0 or B is 0. Okay? So that's why it's a factoring problem. Factoring problems take this expression and turn it into the product of two things. So what's the greatest number I can pull out?
Be 5.
It's the greatest letter?
Just x.
What's left behind after I do that division?
Sorry, 8.
Hold on now, does 8 times 5x equal 40x squared?
No.
Okay, then 8's not correct.
8x.
There you go. Always do that step in your head, because it'll always tell you when you make a mistake.
Okay.
What goes here?
Okay, it'd be minus 3, right?
Does 3 times 5x equal, actually does minus 3 times 5x equal minus 15x?
Yes.
Then you did it right.
Okay.
Now, what are my two solutions? Remember, I'm looking at a quadratic to start with, so I'm expecting to find two solutions.
Okay, so x equals 0 is one of them.
Okay, that's based on this.
Okay, so then, let's see. You have to divide by the 8 and the 3 to get 3/8.
Yeah, but because it's complicated, let's write it out. What this means is that 8x minus 3 has to be equal to 0. And now we have a relatively simple equation to solve. So how do I solve that?
You divide.
First of all, I want to isolate x.
You add the 3.
Okay, so I got 8x equal 3. Now I divide. So there's my second solution.
Okay.
Okay.
Okay. This one is it's 20x squared plus 8x equals 0.
Greatest common factor.
It'll be 4.
For what?
Oh, 4x.
Okay. What's left over?
Okay, so it'll be 5x, and then plus 4, plus 2.
My solutions?
Okay, x equals 0, and then you'd subtract the 2,
Okay.
and give it to the other side.
So, actually, let's just go ahead and do it the hard way.
Okay.
By doing it the hard way, you ensure that you do not make any mistakes. And it's fairly easy to make a mistake if you do it all at one step.
That's true.
In other words, if you try to set that equal to 0 in your head and come up with minus 2/5, it's real easy to come up, first of all, with minus 5/2. So it's real easy to get these reversed if you try to do it in your head. And I don't mean you, I mean everyone. I would not do this in my head. I would do it this way right here.
Okay.
Just to make sure I don't make mistakes. A lot of the key to being good at math is not just understanding the methodologies involved, but making sure that you don't make mistakes. And the key to not making mistakes is to follow the same methodology every time.
Okay.
What else?
Okay, this one, says find the product.
Okay.
And it's 3x squared plus 4x plus 5. And in the second one, it's x plus 2.
Okay. That's our answer.
Okay, so we would do the ET, right? Okay, so it would be 3x the third.
Okay.
Okay, and then it would be 6x squared
Let's
plus 6x squared.
plus. We need that sign. In other words, I can't ignore that.
Okay.
Not like I can write this.
Right.
Because it's being added to the first term. It's not, I can't assume a plus there. If I just give this as an answer, it doesn't really have much meaning. So if I don't put that plus there, it makes a big difference.
Okay.
What next?
Okay, so then you do minus 4x squared.
Plus 4x squared?
It'll be...
That's a plus?
Oh, that was actually a minus. I'm sorry.
That's a plus? They're all pluses, so there's no minuses in this problem.
But no, well, with the negative, it's the positive 4x is a negative 4x. That was my fault.
Okay, I got you.
I'm sorry.
No, that was probably, I probably didn't hear you properly. Okay, so this does become minus 4x squared, okay.
Okay, and then it would be negative 8x.
Okay.
And then you would do 5x plus 5x. And then you do plus 10.
Okay. Perfect. Always use that same methodology going from left to right and complete every term before you go to the right. Now simplify. I always know in my simplification that I've got that. The only terms that are going to simplify are the ones in the middle.
Okay.
How many x squareds do we have?
Sorry, we have 2 x squared.
And how many x's?
1, oh no, sorry, 2, so it'll be negative 3x.
There's your answer.
Okay. Awesome. Okay, this one says find the product, and it is, sorry, the first set of parentheses is 3x minus 2, and in the second set it's 2x plus 6. Okay, so you do 3 times 2, which is 6x, right?
Well, it's 3x times 2x.
Oh, that'd be 6x squared.
There you go. Yeah, don't forget to add those exponents when you're multiplying the variable part of that.
Okay.
In other words, 3x times just 2 is equal to 6x. But 3x times 2x is a different thing altogether. That's equal to 6, and the x times x is x squared. In other words, you have to multiply both the variables and the numbers.
Okay.
Next.
Would be plus 18x.
Next.
Yeah. It would be minus 4x, and then be minus 12.
Okay.
Okay, so then you could take the 6x squared says the same. Then be plus 14x minus 12.
Good. Okay. Got time for maybe one more.
Okay. This is a very similar one. It's W plus 6 in the first one. And the second one, it's W minus 6.
Okay. What's this look like? Put a name on this.
You're just talking about this. It was about the
Difference of perfect squares.
perfect squares.
So what's the answer without having to FOIL it? What's the answer?
Okay. The W squared, right? And then it would be
There's only going to be two terms. In other words, both middle terms are going to cancel. Notice that that 6W cancels with that minus 6W every time.
okay.
So the last term is just the number.
Oh, so it would just be 6? Or
The
36?
number squared.
36. Oh, that's right.
In other words, if we started with this and I said factor that, you would know that it would instantly turn into W minus 6 times W plus 6.
Okay.
Okay? So it's useful to recognize it in reverse also. Even though they haven't taught it to you yet, it's coming also. I guarantee in the next week you're going to get factoring where there's a constant and also difference of squares.
Okay.
Okay? So it's definitely something you're going to end up doing an awful lot of, is that process right there.
Okay.
All right. Any last questions, Connor?
Nope. That should do
Good
it.
luck on your test tomorrow.
Awesome. Thank you so much for your help.
Talk to you later. Bye-bye.
Okay.